All right. Well, do you want to grab your water real quick? I figure we'll do a cheers with.
I'll wait for the beer.
Okay.
How
All right.
about that?
Yeah, that's a good call. We wouldn't want to jinx it by doing a cheers with water. I like that style. So, well, thank you for jumping on Manufacturing Happy Hour today, Dr. Ropella.
Thank you, Kris, for having me. I enjoy being here.
I was, and just to set the stage for people that are listening out there, we're actually not at the College of Engineering. We're down the street, half a block away at Caffrey's, the local campus pub.
Yes, it's a favorite among students and even faculty and staff.
I was going to say, when I was thinking about a good spot to do the interview, because I graduated in 2009, so I didn't actually get to spend any time in the new engineering building aside from coming back. But I'm like, I certainly spent a little bit of time at Caffrey's pub while I was going through school. So it was usually a Friday afternoon after a day of stressful back-to-back tests that we would make our way over here to decompress.
And that's important, right? We all have our different study spaces. I always say, I can tell you that for me personally, I didn't study best in a library. It was really, I prefer actually to sit in the middle of a coffee shop or a cafeteria with lots of background noise and chatter. That it just helps me to focus. It's
funny that you mentioned that, because I was the bridge at Rayner Library, where, if you're not familiar with Marquette, for anyone out there, it's basically a connection between the old library and the new library that was, I guess, completed in the early 2000s and whatnot. But it was really social. It was not meant to be like the hush-hush area. It was like I always did work better with background noise.
Me too. I think the creative juices just flow better when there's other things going in the environment. People watching helps with that sometimes. Sometimes you're just off kind of staring into space. I prefer to have sort of life around me as I'm thinking and writing and reading.
Absolutely. Well, before we get too far, I want to make sure I give you a proper introduction today. So for our audience out there, our guest today is a longtime professor of biomedical engineering who has dove deep into areas like signal processing and functional magnetic resonance imaging in her research. She has earned her PhD at Northwestern University, but before that, she completed her undergraduate journey at Marquette University, where she is now the Dean of the Opus College of Engineering. Ladies and gentlemen, we are joined today by an extraordinary enabler of the next generation of engineers, Dr. Kris Ropella.
Thank you, Kris.
And now that we have our beers here, we can do a proper cheers. Welcome.
Thank you.
So while we're sipping, if you are looking to connect with the College of Engineering or Dr. Ropella, you can find both on Twitter at MU Engineering or at Dean Ropella MU. And that's ROPELLA, correct?
Correct.
All right. Those are the Twitter handles for you. Now, one of the things we do on Manufacturing Happy Hour, one of the goals is to make manufacturing more approachable, current, cool, and technology in general. Same type of thing for that. And I threw out a big term there, functional magnetic resonance imaging. For anyone that might not be familiar with that, let's pretend we're hanging out at a bar, theoretically. How would you explain that to someone that's looking for an intro to that for the first time?
I think that's a great question, and that conversation comes up quite often for me, and how do we make this approachable to people who maybe aren't in the industry? So functional magnetic resonance imaging is really a form of medical imaging that uses what we call magnetic resonance energy. Okay, so it uses magnetic fields. And so magnetic resonance imaging has been around for several decades in terms of imaging, whether it's muscle, brain, oftentimes soft tissue in the body. The functional part came about around the early 1990s when people figured out that they could do magnetic resonance imaging in a way that we could actually observe brain function, not just brain structure. So up until that point, if you image the brain, you would see things like the different lobes of the brain. You actually see anatomy more than anything. And you could see a tumor or, structural type stuff. But when functional came around, you could put somebody in the magnet and you can have them do things like look at something on a screen or listen to auditory music or sounds or do something tactile with their fingers. And while you were doing that, you could take a bunch of images in sequence, almost like if you were running a movie reel.
Yeah.
And you could take images, like, let's say, every couple of seconds, and then you could play those images almost like a reel of movie, and you could see changes in the images over time.
Oh, okay.
And that would allow you to see parts of the brain where those parts of the brain that are processing the visual information or the auditory information would actually show changes in signals as the brain was responding to those changes. So you can think of it, people used to take they used to have like a little deck of cards with something in the corner and the drawing changes from card to card. And as you flip it, you would see the animation, right?
Yep.
It's the same idea, is that you're actually kind of looking at brain images animated over time. And then you look for those parts of the image where things are changing, and
Okay.
most likely it's correlated to whatever activity you're doing.
So you're really seeing brain activity in real time.
Correct.
Is what I'm hearing. Okay.
Correct.
Versus like the structural aspects, which you could previously see before
Correct.
that.
Mhm.
All right. Well, that was an example I could understand
Okay,
at a bar. I'd like to say my Marquette engineering degree has helped to continue to in those capacities. But you've been in biomedical engineering for a long time.
Long time.
I'm curious, why did you go into engineering to begin with? Because I think one thing that's interesting about your full circle is you started as an undergrad here, and now you're the dean of the College of Engineering. But why engineering?
Why
in the first
engineering? I think that's a great question. I did not grow up thinking anything about engineering. Like most, I think people, I had lots of different dreams as a child, everything from being an interior designer to a ballet dancer to, at one point in high school, think about architecture. I used to love to draw and art, and I loved architecture. But as I was leaving high school, I was a good student. So, of course, in those days, if you were a good student, it was like, well, go to medical school or law school. And I started thinking about going to medical school. I was a medical show junkie, and so I used to love watching those kinds of things. I loved the problem solving that was going on in medicine.
Yeah.
And so I was planning to go pre-med, and I needed a major. I loved chemistry, I loved math, but those majors didn't quite appeal to me. And it was really my mother who came home and brought home a brochure from her friend about biomedical engineering. Marquette was one of the few schools in the country that actually offered such a major. So honestly, I opened the brochure, I looked at the curriculum, a lot of different science, a lot of math, only 1 year of English, and no history. That was my major.
Got it. Okay.
So I knew nothing about engineering, and that's how
Yeah.
I picked my major. I would think very differently today, by the way, about the
Sure.
history and English, but that's how I picked it, knowing nothing about engineering. But during my 4 years as an undergrad, I really started to love the engineering classes. I love the problem-solving aspect of it and the application of math and science to being able to address problems and really create technologies that, whether it was fix health issues or whatever it might be. So toward the end of my undergrad, although I applied to I took my medical school entrance exams, I was applying to medical schools. I had an internship at a company called Marquette Electronics.
Okay.
Mike Cudahy is one of Milwaukee's philanthropists.
Yeah.
Ran that company at the time. And I had the good fortune of having 2 summer internships there. And while I was there, I spent a lot of time in the hospital environments, in cardiac care and intensive care units, comparing Marquette monitors to the Hewlett-Packard monitors and how they performed. But during that time, during those summers, I spent a lot of time watching physicians and talking with medical students and watching nurses and doctors. And I realized by the end of my first summer, after my junior year, that I really wasn't that interested in the day-to-day patient care. That's not who I was.
Okay.
I really enjoyed being side by side with the doctors, developing new technologies, thinking about technologies, as opposed to day-to-day patient care. So that's when I thought, I don't think medical school is for me. I'd prefer to just stay in engineering and think about how I advance my knowledge in that area so that I could actually develop the technologies that were so important to healthcare.
Yeah. One thing I love about that story, and that I love about having an engineering degree in general, is it opens so many doors. Like, you can think you're going one path and then you can easily go another. It's a degree that ultimately prepares you for problem solving and navigating complex waters.
It is a great degree, right? It's a great springboard for so many careers. And I think even now, as we think about engineering in the future, it really is around that mindset of, engineers go into all kinds of different professions. So while some might do traditional work, others are going to go on to own their own business. They're going into sales, they're going into law, they're going to medical school. And that problem-solving mindset is so important to all of these fields.
Well, that's really related to my next question, because you were talking about how when you were going through the brochure, the degree checked certain boxes, or maybe more importantly, the boxes it didn't check were what got you into it. But what do you think inspires people today to start an engineering degree or go down that path?
I think it's this idea. I think, first of all, young people are much more informed about the idea of engineering, what engineers do, because K-12 schools and programs have been so much more proactive about doing STEM programming and teaching kids about engineering at a much earlier age. But I think what really excites them is this idea of they can actually solve the world's problems, right? They don't have to just sit around and talk about it. You actually have the skills, the knowledge, experience to really solve real problems. I think people are motivated, whether it's about environmental issues or the next greatest car or airplane or computer and artificial intelligence. I think they see it as empowering and a way to really do good for the world. Hopefully, as a Marquette engineer, do good for the world and use those talents to make the world a better place.
There's a lot to unpack and go into in that answer. I think the first spot I'm going to jump to is I mentioned you're an enabler of the next generation of engineers. You know, I'm curious. Being in academia, you really get to see how people develop through that 4-year process or that graduate process as well too. But what does the engineer of the future look like? And maybe I'll put it in terms I've heard you use before on other interviews, the changing face of engineering. Go into that a little bit.
Yeah, you know, really our sort of our strategic priorities as a college is about changing the face of engineering. And there are really 3 aspects to that. First is changing the face of people who come into the engineering profession, who are participating in the engineering profession. We say if we are truly going to be innovative as a profession, we need to represent people from all walks of life. You know, people with different experiences, backgrounds, knowledge, different lenses on the world. Bring them all together, because it's when you bring those many different viewpoints and disciplines together that innovation truly happens. It doesn't happen when you're only with people who think, look, and act exactly like yourself. So if we're going to be innovative, we need to represent people from all walks of life. We also say if we truly want to serve the world, we need to look more like the world we serve. So that's part of that. And so we do a lot of things around scholarship development, outreach programming, and student success programming in the college to enable a much more diverse spectrum of people to come into engineering and be engineers. The second piece of it is changing the face of our graduates. We don't need the obedient engineer of the past. Most of the obedient stuff that engineers did.
I love that term.
Most of the obedient stuff, which you know too well from some of the classes you took and the things you had to do, you know, a lot of that is being done by computers and AI and other systems. So engineers won't necessarily be doing that. I think the engineer of the future needs greater business acumen. They need to have an entrepreneurial mindset. They need to be more innovative and creative. They need to be risk takers. Who knows what's coming down in the world, and it moves at a really fast pace. So we need people who are really comfortable with being uncomfortable. So I think the more we give students that experience in the classroom to fail quick and to move on and to keep going is a really important aspect. And then because of our Jesuit tradition at Marquette, I think another piece of that is that our graduates will go out and be really ethical leaders. And and be servant leaders. So their mindset is, my job is to be a servant leader and to enable people around me to be truly successful and do it in a very ethical way. So I hope that our graduates, when they're out in that workplace, and they are always saying, just because we can do it doesn't mean we should do it. And they're also not afraid to stand up for, you know, what's just and what's right in terms of things that are happening. And we all see examples every day in corporate America and even academic settings of how ethics is kind of slid out the door as people sort of justify things in terms of money or power or rank, whatever it might be. And so I hope the Marquette engineer takes a different lens on that. And the third piece of it is really changing the face of our college and the way the world looks at us. Does the world look at our college as being global, entrepreneurial, collaborative, innovative, entrepreneurial, risk-taking? And so really thinking about how do we behave as a college, and what's the culture of our college, right? You've heard that expression, you know, culture eats strategy for lunch. Everybody know it. Most organizations we're very aware of that, and there's an intentional focus on cultures in organizations, and a lot of it has to do with leadership. And so one of the things we are focusing very intentionally on our college is leadership and leadership development and our students and our faculty and our staff. And that's very consistent with the Jesuit idea of we are all leaders. But it requires intentional development. We don't leave it just up to chance.
I'm going to go into the leadership topic a little bit more on that. I'm curious because you've been the dean for 4 years now, correct?
Going into my 5th year.
How have you seen things change and seen leadership and getting people to go beyond being the obedient engineer? How have you seen that build into the curriculum, or how have you just seen that change within the fabric of Marquette during your time as dean so far?
That's a great question. I think within the college, we've been very intentional about it in terms of the language that we use and what we're expecting our staff, our faculty, our students to behave as a community. And as I've often said to my faculty and staff, you're all leaders, and it's not okay for any one of you to sit back and wait for everybody else to make change and make things happen. So everybody plays a role, but then let's also respect each person for their role and what they're doing, and that it doesn't matter your title, your name, where you come from, that we are all part of this system that is trying to do good things, particularly along the lines of developing our workforce for the future and student development and student learning. And how does research play into that? How does our formal education play to it? How does our service work play into that? And so we are doing it. I mean, everybody in the college is doing, reading books and doing workshops around, leadership development, their own individual assessments of what are my strengths, what is my disc, what is my, some of those profiling things in terms of who am I and how do I recognize how I'm different from my neighbor and how that affects our relationships with each other. So I think starting at the very top, expectations for how we relate to other people in our college and how we're going to treat them. From a student perspective, we developed a formal program called eLead, which stands for Engineers in the Lead. We started this about 5 years ago. Intentionally, we raised money to do it. We bring in about a cohort of 20 students each year. So in their sophomore year, they can apply for it. We have a formal application process. We have industry folks help us select those cohorts.
Great.
And we bring them in, and they have a 3-year program. Each year has a theme. So the first year theme is leading oneself.
Okay.
The second year is leading with others, and I emphasize with in the Jesuit tradition of servant leadership.
Right.
And the third is leading innovation and technology. So that's layered on top of these other things. And it really has been a great program. We've had over 100 graduates so far. We are tracking our graduates and talking to their employers and, what are the outcomes? Does it make a difference? It's been a very powerful program. And because of that program, I think we have really put or had a great influence on new programs in faculty leadership development on campus. So we've had some input in that and sort of driven the formation of some of those leadership programs. HR is also running leadership programs now for supervisors.
Oh, wow.
And our director, Kate Tree, she directs our engineering leadership programs, has had a voice in those programs and well in terms of how those are being structured. So leadership is one of Marquette's 4 pillars.
Right.
And for 20 some years that I've been here, there was no formal really development about that. Now I think everyone's saying, no, there is a real science and art to leadership development, and it needs to be intentional. It shouldn't just be by accident. And, for years, engineers are often within 5 to 10 years are put into management leadership positions. And many of them fail miserably because nobody ever gave them any tools, education, training on how to do that. And I've heard the stories from many of my engineering friends in the industry, the nightmares. And so why do we wait till people have been out 10 years? Why do you have to learn by trial and error? Why can't you do some programming as an undergraduate to learn about these things?
Yeah. What I love about that, and a parallel I see between Marquette and I guess the manufacturing industry in general, is a lot of times these conversations, which could be very technology centric, really turn to a human element. It's really all about the human engagement, how you work well with others. I think I had another individual on the show before mentioning that, at the end of the day, when you drill down any problem, it's usually, interacting people within people and whatnot versus like the technology itself or the implementation of that.
It's so true. And when you think about when industries fail or a company fails, it's not usually because of the lack of technical expertise. It's usually poor leadership, poor business decisions, and poor culture, right? And so we should address those things because we know particularly many engineers are going to end up in leadership positions or leading their own companies, whatever it might be. And the people piece is the hardest piece. I always like to kid that leadership would be easy if it weren't for the people.
That's right. I say the same thing about my customers in sales sometimes. My job would be so easy if it weren't for my darn customers.
People are complex, and it's beautiful that every individual is different, and humans are created in such complex, diverse spectrum. It's great. It's the beauty of it, but it's also what makes it really challenging when you're trying to lead people through change and motivate large groups of people to move in a certain direction.
Yeah. Well, I think it's really cool that you've implemented that, like the eLead, and for anyone listening, I'll have links to all of this in the show notes. Because when I was going through Marquette, there was always that leadership emphasis, but I feel like it was more emphasized in areas outside of the School of Engineering, like being on the Marquette University student government, leading in extracurriculars, and that can include engineering extracurriculars. And but no, I've kind of peripherally seen that development since I've left. Do you think other schools are doing that? Do you think that's a trend across academia where people are saying, what, engineering is just as much about the leadership as it is about the technology?
I think many schools, engineering schools across the country are talking more and more about how engineers are serving society and making the world better. That's something as a Jesuit school we've talked about a long time. They're starting to put words on that when they can. We're lucky. We're a faith-based institution where we can be very forward and outright about talking about these things, which is a benefit because I think our employers tell us they want to hear that language. They want students to be prepared in those ways. I think a number of your Catholic schools in particular talk a lot about the leadership aspect. I think they see that as a role and a responsibility to society. And so I think we know that there are the American Society of Electrical Engineering now has a division called Engineering Leadership, where they're looking for people to, we've been there at conferences to talk about what we're doing, to write papers about it, and really think about how do we infuse much more of that into the engineering curriculum more intentionally than whatever was done in the past.
Love that. You know, going on that topic, kind of another direction that you mentioned in your previous comment about the engineering of the future and preparing people for the workforce. You mentioned things are getting more automated. The things that engineers were hired to do even 5 or 10 years ago, there's some software or there's some hardware automation to take care of that. And being in manufacturing, we see that all the time. I'm curious, we talked about the leadership element. Are there technical elements that are changing within education in terms of curriculum and preparation for the real world?
Yeah, boy, that's an excellent question. Higher education is undergoing feeling a lot of pressure from all different directions now, whether it's the cost, whether it's technology using the inside and outside the classroom, how we deliver education, what do young people want these days, what are people willing to pay for, how do they use technology to learn. So there are a lot of, the winds of higher education are blowing strong, and there's going to be a lot of disruption. There already is in the next 10 to 20 years, and it's going to be, and we are all kind of just standing there going, where do we go with this? How do we prepare for it? We know the old ways are no longer going to learn. And so you've already seen online education already occurs. And what does that mean? And blended education. And some, faculty have flipped their classrooms. Students want to watch the lectures offline and then come to class and just do active learning in class. And so we think about that.
Oh, that would be cool.
Yeah. So we're doing more and more like of that active learning, project-based learning, challenge-based learning. And we're doing a lot more to bring industry practice into the classroom projects and homework too, so that students aren't just practicing on book examples and imaginary examples, that they are actually seeing that real world challenges are hard. In fact, that's where engineering really happens, right? I mean, theory only goes so far, and when theory no longer works, that's when real engineering happens, right? Like you say, okay, I have these constraints, I have these limitations, the laws of whatever it is fixed don't work here.
Right.
Now how do I design, and now how do I create? And that's where innovation really is called upon. So how do we give students that experience at a much younger age to deal with those challenges and know that there is no right answer, you are going to fail, you got to get back up, and also when is good enough? Company, no product is ever perfect. Wait till it's perfect, it's never going to get out the door.
Exactly.
Right?
Yep.
So the whole decision of when is good enough, and how do you design something that people are going to pay for, the customer really needs, the customer really wants. Sometimes the customer doesn't even know what they want, so you're working together to figure out what that is. And so I think our education needs to be needs to expose students much more to that environment where it's not about getting the perfect answer and getting the A plus, right? Because that's not how you really work. The other thing we need to do is really think about multidisciplinary education. So our engineering students want more business acumen. They want to work on teams with business students and even sociology students and maybe nursing students. And that's the way the real world works. Rarely should you just have engineers working only within themselves. And so how do we give them an opportunity in their undergraduate experience to work across different disciplines? And Marquette's new core curriculum that started about 2 years ago is really designed to be about that, where students will learn things even about theology and philosophy and ethics and that kind of thing, but in the context of some real global challenges and with teams of people from different disciplines. So you can see that, well, a sociologist looks at this different than the economics student, different from the engineering student, and yet you all of those are real constraints that you have to work on to come up with some solutions.
Yeah. What's fun about that is I've heard you use the term putting theory into practice, which I feel like really summarizes everything you just mentioned, where there's not necessarily the right answer. Like you're working within a time constraint, a budget constraint. I remember when I was a student here, when I was doing our capstone senior design project, there was a portion called like the customer feedback portion where you're trying to figure out what the customer wants out of your project. And the ironic thing was that was probably the part of the process that most people slacked on, because they're like, it's not important. We're the engineers. We're gonna design this great thing, and I'm sure they're gonna like it, whatever it is. So, I assume you've probably seen that change over the years too, where that's taken very seriously now.
You've said it very, very well. That's exactly right. Too often the engineers didn't really care what the customer said. I've just got this cool whiz-bang technology, great, and you know what? It sits on a shelf somewhere. It's either too expensive, the user can't use it, whatever. So the emphasis very much now in all of our design courses is it's all about the customer. What's their need? What do they want? You need to listen to that. And that's what drives everything. And I think most of your products that you use out in the world are a testament to that, right? I mean,
For sure.
people introduce new things if no one realizes it. Who cares that you've added on this whiz-bang feature that costs $300 more if no one's going to use it, right? And so there's much more attention, I think, to the customer piece, which means that your marketing people, your ergonomics people, your engineers all have to be in dialogue all the time about these things and have and meet with the customers regularly and get customer feedback on that. The same thing that your engineers also have to pay attention to manufacturing. So I love to always bring up a story of one of my senior design teams. The engineer is designing off in a corner and doesn't pay attention to the fact that you can't manufacturing something of a certain size or a certain material, whatever it might be, right? So I had a senior design team that was working for another company, really smart team, very talented students, and they had to do some electronic board layout. And my husband is a hardware design guy, so he sat down with them on a few Sundays to talk about the design portion. And the very first words out of his mouth were you have to worry about the hole size and trace size on your board because that affects expense and manufacturability. Of course, they really didn't pay attention to that because they were just more concerned about their transistors and microprocessors and where does everything lay on the board.
As many of us were as naive students,
Right. So the best thing is it's a couple days before their final project is due and they have to show a working prototype. And it's like Sunday night at 10 o'clock and I get this call from them in a panic. And like, Doctor, it's 10 o'clock at night. And my husband's listening in on the phone. Dr. Ropella, we don't know what to do. I said, what's wrong? And they said, well, the company we're working for allotted them $400 for the circuit board creation. And they called me and said, we put out a quote and the company that does the circuit boards got back to us. And I said, yes. And they said, and the quote's $4,000. I said, and my husband's laughing in the background. And I said, and why is it so expensive? They said, our holes are too small and our traces are too narrow, too thin. And my husband's laughing. I said, he goes, that's the first thing I told you when we met, So, and I said, well, you're going to have to tell this to your sponsor now. The sponsor was great, of course. They're like, good learning opportunity, learn from this. But you need to think about the manufacturability when you're doing this, right? It's a real thing. And so, again, they learned the hard way, maybe a failure, but fortunately it was a failure that wasn't a big deal, but they'll never forget that.
Oh, absolutely. Absolutely. And I love that you brought it all together with a story that contextualizes that too, because that's always the best way to end a round of our interview. So we got plenty more to come here, but we're going to take a quick pause. For those of you listening, we'll be right back with round 2 in just a moment. We're back. All right. Well, cheers to round 2.
Cheers to round 2.
Only way to start. So I wanted to have some fun to kick this part off of the interview. When I was researching for this, one of the things that comes up when you search for Kris Ropella online is your accomplishments in dancing. So you're an avid dancer, and I always love drawing parallels between like hobbies and extracurriculars and like the work we do. So, how has dancing impacted your approach to engineering, leadership, and your professional style in general? I'm curious.
That's a great question. I love dance. I've loved dance since I was a very small child in the sense of I can watch it for hours. I did some ballet when I was a kid. I was a gymnast, used it, but I didn't have a lot of formal training, although I've always loved club dancing. Put me at a wedding and I'll dance till the very last song kind of thing. To me, it's a lot about creativity. So dance, I love music. I've always loved music. I played instruments and I love the fine arts in general. And I just think they make me use that other part of my brain that's actually really important to engineering work, which is creativity and being able to see the world differently, feel the world differently. Music is full of lots of complex tones. And if you think about, I always think of the orchestra, which every instrument plays their own little part, but it isn't until you bring it all together that you hear the beauty and the richness of music, right? And engineering is the same way, right? You might have your own little, you're creating your own little widget, your own little piece of code or whatever, but it isn't until you bring together, let's say, even multiple disciplines and the whole system together where it's moving all together that you start to appreciate the beauty and the power of what that technology does. So I think about many of our engineering students are involved in music, in art, in sports, all kinds of other extracurriculars. And we actually encourage it because I'm a big believer in sound mind, sound body. So I think fitness is really important. And that's what dance has done for me as well, as lets you work on that part of your body as well. Gives you the time to think, gives you the mind time to be away from work and what you do every day, and puts your mind in other spaces where you're thinking about it. You have the freedom to think about other things that you may think are unrelated, but yet, those creative processes and all of a sudden linking things that normally seem unconnected is what engineering is really all about. Innovation engineering is about, oh, I see this thing going on in this field, and and I never realized it, but you can actually draw some parallels. And then all of a sudden you're like, all of a sudden we're bringing this from this field and bringing this from field, and we're making something new that we never did before. So that's why I think those, at least my time in dance for me, not only is it just great workout and mentally it gives me that break from work, but and I'm spending time in music, and I'm spending time, believe it or not, the dance teachers all know when we're engineers.
Okay.
Because they say we're very analytical, right? Like they have to explain everything to us and breaking it down into pieces and how does it all fit together. And we really do think about angles and curvature and that kind of stuff.
Keep going. I'm having some realizations of my own right now too.
And we're worried about the speed. And do you really mean this angle? And sometimes they're like, don't be so literal, like just dance and just feel it. But
go with the flow.
But we're counting half measures and whole measures, and and so they laugh because like, okay, I'm going to put in engineering terms. Here's your analysis that you're looking for. So in that piece of it, we laugh about it. And so we tend to learn maybe the way we do it a little differently than someone who doesn't come out of that background. But it just allows us to put the brain into, I think, a different place in a different space. And see and feel the world differently in that space, and that all of a sudden we kind of bring that to some of the things that we're doing in engineering.
Love that. And we talked about some of your research specialties earlier. What are your dance specialties then?
My dance specialties. So I've been doing ballroom dance. I got into it a couple years ago. I did a fundraiser for Cristo Rey High School here in Milwaukee. They had a Dancing with the Stars. Was no intention of doing it seriously once this contest was over, but I really, really loved it. So I do a variety of things. I do what are called the rhythm dances. So your cha-cha, rumba, swing, mambo, salsa, those kinds of dances. We also do what are called the Latin dances, which are also a Latin version of cha-cha and a Latin version of rumba, but also something called samba and jive and, some of those dances, which those are more the fast dances, if you can think of it. Yeah. And then I also do some of the smooth, so the waltzes, Viennese waltz, tango, foxtrot. And so that's very different. Those are the big long ball gowns, and it's a very smooth kind of dance and very different. But believe it or not, they actually do complement each other well, and what you're learning, one cares about. So it's a lot of workout. It is power with grace, if you want to think about it that way. But more so, it is really about, there's definite technique to it. There's discipline in it. And what I didn't really appreciate that I do now is that these dancers make really hard stuff look really easy.
Yes.
Right? And so, and they teach it to me, a lot of stuff they teach me in terms of physics. So it's moments of inertia, it's forces, it's momentum. And so it really is a lot of engineering in the context of how we learn dance.
Well, my one dance style I can do is salsa.
There you go.
And I'm super analytical about it as well. So as you were saying, it's like, that's why I'm really weird about really trying to remember specifically what turn to do what time, what flows with what. So thank you for the personal life realization as well, too. That helped quite a bit. There is a reason for that question, though, and that's we've talked about leadership. We've talked a little about how we're involving the ability to fail and technology within a curriculum. How are some specific ways you're bringing creativity into your curriculum as well now?
I think that's a great question, and it's always a challenge. I think especially if faculty who are teaching classes have only been trained in a certain way in a very more traditional engineering. How do you help them to introduce more creative stuff into their work? So the classes that are easiest are engineering design classes, right? You have faculty who actually teach still how to do sketching and drawing by hand, something that people don't do very often anymore. How do you do computer animation? How do you think they might do some of these more formal ideation workshops, that people like IDEO like to do, where you're brainstorming new ideas and putting them up and nobody's allowed to turn anything down in the beginning and just what are your craziest thoughts, to some of the stuff we do in eLead where we're talking about innovation and we have students say, think of one of your favorite products that you absolutely love that you use every single day, right? Yep. And then you meet up with your neighbor and you share your favorite products, and then within a few minutes you have to come up with something new that integrates both of those. So it's like, well, how is a cell phone related to toilet paper or something like that? And how do you come up with new? Yeah. Okay. So just forcing.
How is a cell phone related to toilet? Well, that was just an example.
That's you to think about it, right?
All right. Okay. That's for me to answer later.
Right. You have to think about that later. Right. But forcing them to think two things that they normally would never put in the same playground together, all of a sudden going, well, now we're going to force you to. How might you combine the best of these two products into something very different that makes life better? And so I think it's anytime you give people an opportunity to think differently, put them in a space they haven't been before and say, we're going to give you a problem set that you have to solve in so much time. All of a sudden it starts forcing them to be creative, especially if you put a time constraint or a money constraint on it, or, you have to do it by the end of this afternoon and you've got, 4 hours to get done.
Yeah.
It's amazing how all of a sudden people can become really creative versus giving them all the time in the world. So, it's the projects that we assign, hopefully, even with industry, maybe giving them something that seems sort of far-fetched or some project that's way off on the shelf somewhere and bringing it to life and saying, okay, we're giving you a chance to tinker with this.
Yeah.
As well as extracurriculars. Our students are so involved in running student organizations, whether it's student government or it's the Baja, race car team or concrete canoe or coming up with the next great STEM kit for outreach classes. And that's where students have an opportunity, not under the pressure of grades, to really just be creative and try something different and try something innovative. So that's another way in which we do it.
Well, do you have a recent example, like I guess a story that kind of contextualizes creativity in the College of Engineering recently?
Oh boy, let me think here for a minute. Trying to think of some of the most creative things that have happened recently and what our students are doing. Well, we have a student who graduated just a couple years ago who used to make handmade guitars.
Oh, no way. That's pretty cool.
Yeah, it's really cool, right?
I would buy one of those.
Yeah,
actually.
he was really into music and guitars. So he used to do handmade guitars, and he often perfected with things that he was doing in our shops. We have students who are designing robots to do, different things. Oh, I know. I'll give you an example. So we had a group of women, a senior design team in the last 2 years, who have either because of their own industry experience or experience of people they know, hate this idea that when women want to go into manufacturing areas, they have to wear these steel-toed shoes that are made for men, these big, clunky, ugly things, right?
Wait a second. Did that come out of Marquette?
Yeah, some of it did, yes.
Okay. All right. Keep going.
And
I just learned about this,
and so
Monday.
why do the women have to wear the ugly men's shoes? And they don't look at it. So they got together and created a team with the intention of creating a business of we're going to create steel-toed shoes for women in women's design. So women could still wear their high heels or women's-style loafers or whatever it might be. So they don't have to wear the ugly stuff, but they can wear it. So they worked on it. That's what they worked on, and they had help from some, actually a gentleman that I know who's in kind of the shoe manufacturing area who helped them develop a phototype and actually came up with some really nice prototypes of a female shoe that you can wear in a manufacturing environment.
Their Instagram profile looks great.
Right.
I think, by the way, if you're listening, I think Anna is the name of the founder.
There's a couple of them.
I was going to say, I was just introduced to her the other day, so hopefully if you're listening to this, you're about to be featured on the show sometime soon, because I was just like, that's a perfect idea. It's an excellent idea.
Yeah,
Sorry,
there's a faculty member at Mount Mary who had the same concern. She wants these kind of shoes too. We have our own engineering students doing this stuff and still working on it. And actually, there's a number of I've been introduced through. I'm on the board of trustees at the Medical College of Wisconsin, and there's some other women on there, and one of them has gotten involved in an organization of women-led fashion industries, right? Clothing, shoes, etc., who are really getting it together to look at how advanced manufacturing can change the way we create women's fashions and clothing, including 3D printing and stuff like that. So you'd have custom, your outfit be customly made to you using 3D printing technology and those sorts of things. So again, all of a sudden women, you bring them to the industry are saying, you know what, we could do things differently for us too.
Yeah, no kidding. I think it's called Xena footwear.
Might be. I don't know what that company is, but there's a couple of groups working on this.
I'll have to double check on that, but I literally just learned about this yesterday, and I saw kind of just the branding around it. I'm like, this is excellent. It's solving a problem that I've heard about from my female colleagues in the industry before. I just thought it was wonderful when I was learning about it. We've kind of shifting gears a little bit. We have a lot of people in the manufacturing industry that you kind of hinted at it before. People that are leaders in the manufacturing space, are becoming leaders, but weren't trained to be a leader at some point. I'm curious. We've talked about education in the context of academia at a spot like Marquette. What can leaders in the manufacturing space, as well as people that are just getting into it or working in the manufacturing space, do to continue to make education a priority in their lives once they get to the field and their mentality might be like, oh, well, my job is to do my job right now, and sometimes you lose that will or that thought that you need to keep learning?
Yeah, you ask a great question. It's something we're thinking about a lot. We've sort of in the last couple of years gotten some funding from a major foundation to rethink what we're doing in the graduate education space. So people who've already graduated, they're out in the field practicing, and they want to do they want to continue learning. They might even want to sort of change their field, or they didn't get enough in their undergraduate. They want to come up to some speed in some other areas. So we think about, how do we help those professionals? They're working long days, they're working long weeks. They may not even be able to come to campus. And what do they need? So we've spent the last 2 years doing a lot of market research and talking with industry, people practicing industry about, what do you need? What do you want to learn? What do you think you need to be doing? And we are in the process of creating some certificate programs. Maybe they don't have to be full graduate degrees, but even workshops and stuff that would be easy and accessible and affordable to the working professionals to do more of this continuing education sort of thing. One of those areas happens to be leadership. So we're actually taking sort of elements of our eLead program, and we're going on to industry now to offer some leadership development for their young engineer, early stage or early career engineers, right?
Yeah.
And other people in company. And we actually have a company in Mequon now who's agreed to be sort of a guinea pig on our first trial on this. So we're going to have like a 5 to 7 week program where we've taken a cohort of about 25 of their employees, and we're doing this leadership development program. And we've spent a lot of time sitting down with company and saying, tell us about your mission, tell us about what you're ready to do in leadership development, tell us about what your needs, what would you like the outcome to be, and trying to really tailor a program to them. So we want to do much more of that as well to help serve companies, particularly small companies who may not have the resources to do leadership development. And I think manufacturing is a great area. I probably walk a manufacturing floor at least once a month, and I love doing it. I learn so much, not only about technology, but just about the entire manufacturing operation. And I think there are such great leadership opportunities there. If people would know about engineers, and particularly women, like I think women would love this, because it's not just the technology, it's people, it's supply chain, it's economics, it's operations, and like a VP of engineering, there's so much you're responsible for, and it's so cool, and it's a great leadership opportunity. But most people know nothing that goes on in manufacturing. They don't see it. I mean, when I was a kid, the only manufacturing you saw was the beer bottling lines at Miller or Pabst, right? That's what you grew up thinking.
Milwaukee
It's a very Milwaukee thing.
I don't know, Harley manufacturing too. That's got to be in there.
Right, whoever had the cool tours, right?
Right.
But you didn't even think about manufacturing, or you were still under that idea 20, 30 years ago it was very dirty and it was someone in a machine shop, whatever.
Yeah.
But manufacturing isn't like that at all anymore. Most of it's very clean. It's automated. It's I think a much better environment for the workers and the people who are working in it, and they have greater leadership roles and they have greater autonomy in what they do. So I just think it's evolved to such a great place that more of our engineers, if they knew about it, I think would be more interested in leadership positions in manufacturing.
Sure. Well, I love the examples you gave there. I guess to make it kind of a personal question as well too, what are the things you do to stay sharp?
What do I do to stay sharp?
Yeah, I'm curious, because I think there's a lot to be learned from maybe some of your best practices as well for someone that's leading a program like the Engineering School at Marquette.
Yeah. So leadership books and leadership articles are kind of a hobby for me. It sounds weird, but I have stacks on my nightstand in my bedroom, stacks in my office, stacks in my family room. So I read a lot just because I find all the books give you little morsels of things that you can be practicing and putting into practice, whether it's like Patrick Lencioni's books or Daniel Goleman on emotional intelligence. Those are some of my early books. Chris Lowney, who is a favorite in this university around heroic leadership and sort of leadership in the Jesuit context. Great book, right? So those are really good foundations. I also, before I even became a department chair, the Whitaker Foundation held these great leadership development workshops for many of us faculty who they thought would eventually end up in academic leadership. And those workshops were great too. They were facilitators who ran those things for 3 or 4 days, and you did everything from simulations to learning about leadership theory to emotional intelligence and some of your personality profiles. So that was some great exposure to those ideas and those concepts early on, and that's what kind of got me all excited about it. So I do a lot of reading in it. I go to conferences, I go to meetings that talk about leadership, and a lot of it's just through practice. So I take what I read and I really just try to put it into practice. And many times it works, sometimes it fails, and you have to change course. But it's just a willingness, as you say, to always be saying, it's a lifelong journey for me. I'm never the perfect leader. I'm never at an endpoint in leadership. I have to keep learning. And leadership has changed over times. The early industrial revolution was much more about, the leadership pyramid. That one person on top just telling everybody what to do, and everybody told the line and did it. It's changing. Young people I don't even think are attracted to that model anymore, right? And we talk much more about flipping the pyramid and shared leadership, and everybody has a role. And how do you operate more in the environment, and how do you give the people around you more autonomy? And, I see my job, honestly, as the dean of the college, my job is to try and provide the resources and foundations so everybody else can be really, truly successful in the organization. That's my job.
Yeah.
And so how do I give them what they need? And that includes the freedom to do what they do, and the autonomy. And sometimes they're going to make mistakes, and they're going to do things that not the way I would do it. But that's all part of them taking ownership of what they do and feeling like they're an important part of the organization and they're part of our leadership.
Yeah. Well, I think, what is the term? Servant leadership?
Yes.
Where you're really trying to enable the success of others in that case. And I know that's not necessarily the perfect definition around it, but that's one of the big takeaways I have from that. I'm thinking about this in the context of the manufacturing industry as well. And you've talked about flipping that leadership pyramid, and there is that shared leadership now. And like you've mentioned before, there's more diversity in the changing face of engineering, whether that's gender diversity, ethnic diversity. What would be your practical advice to the leaders and listeners of this show that are trying to have those more courageous conversations, or trying to really take advantage of that diversity of thought and experience that might be, let's be honest, uncomfortable conversations or uncomfortable topics to address today?
Yeah, that's a great question. And I think first you have to do is look in the mirror. And that's the hardest thing. So you look at your organization in the mirror and say, what do we see? What do we look like? What voices are missing from this? What faces are missing from this? What are we not thinking about? And that's hard to do because nobody wants to, especially if you've gotten very comfortable in your organization and people all of a sudden, you hear the expression, oh, we're just like family. Well, I was at a conference once when a facilitator at a meeting said, people always think that expression, we're just like family, is a good thing, but many families are really dysfunctional.
That's a fair point.
And so gave a different viewpoint of, some families tend to be insular and don't want anybody coming in from the outside. They're very stuck on their traditions and don't want to think differently. So that gave me a whole different feeling of, when you all are too much of the same mindset, same look, you tend to, group think, and you tend to not things differently. So I think the recommendation is, and we have to practice, is to invite those people in the room who haven't been in the room before. And sometimes that's hard. And for us, we have to remember that. So, at least a small step I think that I wanted to do when I became dean is when our college was doing things like strategic planning, everybody in the college is invited. It used to be just faculty were in those meetings. Well, what about all of our staff who are really important to the college, and they're often the front lines to students and parents coming in to visit the college. And so they should all be part of it too, and our students should be part of it because it takes all of these people to make us work. And so inviting in and you know how that goes. So I'm like, well, that person's going to be disruptive, or that person doesn't agree with us. Right. Yeah, but you know what? You have to hear that voice because when you put stuff out to the public, those other people with that same voice are going to be out there.
Right.
Better learn how to deal with it now, how to talk about it now, then wait until the big masses are coming in and raising all those same questions that you were trying to avoid.
Especially in the world of social media and third-party validation now, it's more important than ever.
Yeah.
Well, that's great. Yeah, we've covered a broad range of topics today. I appreciate everything you've done. I've got a few more tactical questions for us before we wrap up. You mentioned a couple great books to check out. One of the ones that sticks out for me is Historic Leadership. Everything, by the way, anyone listening, everything we mentioned in this interview, I'll have in the show notes. But from an engineer of the future standpoint, maybe something engineering oriented, what's a book or resource you'd recommend? If someone wants to get spun up on that.
Wow. Gosh, there's so many good ones. And again, sitting on my desk, I'm trying to think. Well, actually, from a leadership point of view, a book I really like is Lead Like a Guide. I think it's something.
I haven't heard of that one.
Yeah, read that. Okay. It's a nice narrow book, and it's written by the guides who lead people up things like Mount Kilimanjaro and those places, and how you get every individual person to be their best. So that's a good one too, with lots of little vignette stories, of these guides have had. But from a technology point of view, wow. Got to think. I've got a huge stack. Innovator's DNA, I think, is one that we've been using in the college as sort of a resource for everybody to be thinking about how we're all innovative. We all have to bring out that innovative spirit and that innovative DNA in us. And it doesn't matter if you're doing the IT in our building or the machine shop or you're actually teaching classes. How do you bring that innovative spirit into all that we do? So we're all using that book, and I think that's a nice one to go from. And,
that's a good list so far.
Wait, one more. Thank you, Lex, for reminding me of one. The Power of Moments. So I actually want to credit Tim Bergstrom of Bergstrom Automotive in the Appleton, Green Bay area. A year ago, one of my family members had a serious health issue, and he was with me at a time when I first was aware of it. It was very hard, and he sent me this beautiful book called The Power of Moments, and it really is an excellent book. I'm drawing on forgetting who the author is at the moment, but it really is about how people tend to remember moments, like special moments, and how can you do more to create those special moments in your workplace, in your home, in your communities? How do you create those special moments for people? Because that's what people will remember over the long time, not the day-to-day stuff that we all think is so important, right? So I highly recommend that, and that's another book I've given a number of leadership in our college, so people can think about how do you create special moments for people.
Love that. I'll have links to all of those in the show notes, and I'm just now thinking back to all my Marquette moments as well too. As we're getting
think about that.
Yeah, there's a few happened in this
Your
bar
Caffrey
as well
moments.
too. Yeah, exactly. And I remember them pretty well, to my credit. So anyway, but that's a different podcast, so we'll save that for another day. You know, as we're nearing the end, what's something you wish I would have asked you that I haven't yet?
Oh, that's excellent. You know, one of my favorite questions I think that people ask me is, what would you have told your 20-year-old self? You know, what would have been something? Good one. And I think along that lines, it is about live in the moment, and something I still work on as a person. You know, I think in a leadership role, you tend to always be looking at the future. Where do we need to be? What's the vision? Where are we going? And that's fun and it's exciting. But sometimes in doing that, and all the anxiety that tends to go along with that too, is we forget to live in the moment and just celebrate the moment that we're in. And we don't know if the future is coming. We don't know where it's going to be. So don't forget to celebrate the now and to appreciate the now, and let your people know now you're doing good things, and practice gratitude. So that's something that we talk a lot about at Marquette. And so in every day, despite frustrations or challenges we're dealing with, how do we practice gratitude? Remember to be grateful for the things that we have, and do it on a regular basis, because it sure makes life a lot more enjoyable when we do that.
Awesome. Well, I like the moment theme that we've had here towards the end of the episode, and all the great tips and tactics and stories you've shared throughout the interview. As we wrap up, last question. What's next for you in Marquette University?
Oh, my goodness. What is next? I don't know what's next for me. As a college, we're moving along with a concept of something called Innovation Alley, which is how do we create the people, the programs, and the spaces that allow us to be really a leader in what we call innovation leadership. We hear from companies all the time, we lack leaders who really understand how to be innovative. How do we continue to be innovative? Our companies otherwise will fold. How do organizations? So we're starting a whole lot of more formal programming around that development and some of the spaces that go along with it. So it's raising the money. We have donors who are interested and companies are interested, but we want companies to be an important part of that. So how do we think differently about how industry, academic relationships occur in those models to better serve society, to do better work as academics, to do better work as industry, and to work together to be more innovative in what we do, because there's a lot of disruption in both our spaces. And so how do we work more together? And that's one of the projects some of the things that I'm working on, is just those industry academic relationships. Innovation Alley, I've recently heard about that as well too. Innovation Alley will be linked up after this episode. In the meantime, Dr. Ropella, thanks so much for being on Manufacturing Happy Hour today. Well, Kris, thank you for giving me this opportunity. It was absolutely delightful, and keep up this great work. It's people need to hear about these things that you're talking about. Hey, it's a lot of fun. It's always good to have an excuse to come back to campus as well, too. And for everyone else listening, stay innovative, stay thirsty. We'll catch you again here on the show real soon. Cheers.